Let's jump into something that feels like it belongs in myth, but is absolutely shaping our present and future.
Mm,
The idea of thinking machines.
right.
We're not just talking about robots from the movies, you know.
Yeah.
We're diving deep into the history, the philosophical debates, and the really pressing ethical questions artificial intelligence is bringing up right now.
It's a huge topic.
Totally. And we've got a fascinating stack of source material from one of you covering everything from historical deep dives and, well, pretty dense philosophical papers to, yes, a community discussion thread about the famous ban on thinking machines in Dune.
Ah, Dune. It's remarkable how that fictional concept, like the Butlerian Jihad's dramatic commandment, thou shalt not make a machine in the likeness of a human mind, it really puts a finger on the core tension, doesn't it?
It really does.
It sparks questions that resonate so deeply with real-world debates. What is intelligence when we apply it to machines? Can we truly replicate the human mind? And maybe most importantly, should we?
Absolutely. Our goal in this deep dive is, well, to help you navigate this complex landscape.
Yeah.
We want to show you where the dream of AI came from, how it evolved into the technology surrounding us today, and what it all means for our future.
Yeah.
It's a journey that spans centuries, connects ancient texts to modern code, and reveals how fiction sometimes holds a mirror up to our deepest hopes and maybe our fears about creation.
And this dive will connect those often separate discussions. It shows how humanity's, centuries-old aspirations and anxieties, they actually inform the technology shaping your daily life and the profound ethical considerations we're grappling with.
Not just in some abstract future, right?
No, right now, today.
So where does this incredible idea even begin?
Hmm.
Honestly, it feels almost as old as humanity itself. You see this ambition, this kind of urge to imbue inanimate objects with life or intelligence, stretching all the way back to ancient myths. Homer, for example, wrote about automatons, these mechanical servants crafted by the god Hephaestus. It's this persistent human dream, this yearning to create artificial beings that can act and think for us.
And that dream wasn't just confined to physical creations. It quickly moved into philosophical realms, exploring the very idea of automating thought, logic, even, truth-finding.
Automating truth-finding, wow.
Yeah, take Ramon Lull, a philosopher from the 13th century. He devised this system, he called it combinatorial art. It used rotating discs inscribed with concepts like the attributes of God, goodness, greatness, eternity.
Okay.
He genuinely believed you could mechanically combine these concepts in a logical way to discover truth, almost like a machine for theological debate. He dreamed of a universal language built on this principle.
So it's like a medieval algorithm for finding divine truth,
That's fascinating.
pretty much.
And this thread continues, doesn't it? Fast forward to the 17th century with Gottfried Leibniz, who was actually influenced by Lull.
Leibniz proposed an alphabet of human thought, the idea that all complex concepts could be broken down into simpler, fundamental ideas, like words are built from letters. And he echoed Thomas Hobbes, believing that everything done by our mind is a computation.
That classic line, let us calculate.
Exactly. Leibniz famously envisioned settling disputes not with arguments, but by simply saying, let us calculate without further ado to see who is right.
That idea that thinking is fundamentally a form of computation is incredibly powerful and, like you said, foundational to how we think about AI today.
Mm-hmm.
And then there's Jonathan Swift, who, in Gulliver's Travels, gave us this wonderful piece of satire. His description of the engine, a device that generated random permutations of words to produce ideas.
Right, the word generating machine.
Swift was poking fun at these combinatorial systems, but it's striking how this concept of random text generation in the 18th century seems to prefigure modern algorithmic text generation and, well, in a sense, even approaches like brute force deep learning that explore vast possibility spaces.
It's almost like satire can accidentally stumble onto predictive power.
Sometimes it feels that way.
Beyond the purely philosophical, there were tangible, if mechanical, steps towards creating artificial systems. Think about Leonardo Torres y Quevedo's El Ajedrecista from 1914.
The chess player.
Yeah, this was the first automated chess-playing machine using electromagnets. It could play a simple king and rook versus king endgame entirely automatically.
Yeah.
It even recognized and signaled if the human player made an illegal move.
Pretty impressive for 1914. And then just a few years later, 1921, Carol Apek's play RUR introduced a word that would become synonymous with artificial beings. robot.
Ah, the origin of robot.
Right, from the Czech word robota, meaning forced labor or drudgery. Although Apex's original robots were biological, the term quickly attached itself to mechanical laborers built to do difficult or monotonous tasks.
Which leads us, inevitably, to the electronic age. Early electronic computers, like the Atanasoff Berry computer, the ABC, utilized vacuum tubes to perform logic operations at speeds previously unimaginable for mechanical devices. This was a crucial step, showing that machines could perform complex calculations and process information in ways that seemed to mimic aspects of thought.
And this period also saw the birth of the core scientific concepts that would underpin the field. In 1943, Warren McCulloch and Walter Pitts published their seminal paper suggesting the brain itself could be modeled as a computational system.
And they introduced artificial neural networks.
Exactly, which are, of course, absolutely central to deep learning today.
And then, maybe the most famous early definition, Alan Turing's 1950 paper and the Turing test.
The imitation game.
Right. He proposed a measure of machine intelligence based purely on behavior. Could machine convince a human interlocutor that it was also human through conversation? It gave the nascent field a concrete operational goal.
Even if it sparked endless debate about whether mimicking intelligence is the same as actually possessing it.
A debate that's still going on, really.
Absolutely. And these concepts culminated in the formal birth of AI as a discipline.
Right, the moment AI got its name. It formally began with the 1956 Dartmouth workshop. This is where John McCarthy, one of the key figures, coined the term artificial intelligence.
A big moment.
Huge. The proposal for the workshop was built on a really ambitious idea, McCarthy's conjecture, that every aspect of learning or any other feature of intelligence could, in principle, be so precisely described that a machine could be made to simulate it.
The air was thick with optimism then. They had incredibly high hopes, genuinely believing they could achieve human-level intelligence within a generation, maybe even years.
Seems wild now, but...
Well, they dove right in, building early programs based on these ideas. There was Minsky and Edmonds Snark, an early attempt at a neural network trying to model simple learning.
Just snark?
Yeah, and Oliver Selfridge developed the pandemonium model for pattern recognition, imagining these layers of demons or processing units, shouting to recognize features in an image, sort of hierarchical processing.
Like little agents working together.
Kind of. McCarthy himself worked on the advice taker, an early attempt to build a system that could reason using common sense by manipulating sentences in formal logic.
Trying to capture common sense. That's still a massive challenge.
Oh, definitely. And then in 1966, Joseph Weizenbaum created ELIZA.
Ah, the therapist program.
Right, it just used pattern matching to mimic the responses of a Rogerian psychotherapist. But what was truly surprising was how readily people talking to ELIZA attributed human-like feelings and understanding to it, even though it had none.
That's fascinating. It raised early questions about how we interact with and perceive these systems.
It really did. We also saw the rise of expert systems, like Dendrol, which could simulate the decision-making process of an expert organic chemist. Shaky the Robot was a landmark project combining perception, planning, and problem-solving in a physical agent.
So lots of different approaches being tried.
Absolutely. It was an era of bold predictions, like Marvin Minsky's famous claim in the late 60s that the problem of creating artificial intelligence would be largely solved within 3 to 8 years.
Which, looking back, feels incredibly optimistic.
Hugely optimistic. And it sparked early philosophical pushback, too. Hubert Dreyfus, for instance, published critiques arguing that fundamental aspects of human intelligence like intuition, tacit knowledge, understanding context couldn't be captured by the symbol manipulation and rule-based systems AI was focused on then.
He thought there were limits.
Yeah, he predicted limits to replicating human capabilities with purely computational approaches, at least as they were conceived at the time.
And this highlighted the ongoing struggle to define what they were even building. What does intelligence mean when applied to a machine?
Exactly. Is it about general, flexible capability, like Charles Spearman's idea of a general intelligence factor, G, or is it just about excelling at specific tasks?
Like, if a machine can beat the world champion at chess, is it truly intelligent in the human sense, or just incredibly good at one narrow thing?
That's the question. It brings up that core analogy is a computer at its base, just a complex flowchart, or a vast network of switches. If so, is human consciousness just incredibly complex computation happening in our brains?
Big questions.
Huge. The computer scientist's perspective often defaulted to viewing intelligence more pragmatically. as a type of observable behavior, whatever the underlying mechanism.
Which is a useful way to think about it, maybe.
It helped categorize the different levels of AI we still discuss today. First, artificial narrow intelligence, or ANI.
Okay.
This is AI designed to excel at a single specific task. Think of a system that's great at playing chess, or recommending products, or recognizing faces. Most of the AI you interact with daily falls into this category.
Right, like my phone's assistant or Netflix recommendation.
Exactly. Then there's artificial general intelligence, or AGI. This is the dream of creating AI with human-level flexibility and intelligence across a wide range of tasks. It could learn and adapt to new challenges, just like a human can.
The sci-fi AI,
Yeah.
basically, which we don't have yet.
Not yet, no. And finally, artificial superintelligence, or ASI. This is the theoretical level where AI is not just equal to human intelligence, but vastly superior across virtually every domain. Scientific creativity, general wisdom, social skills, you name it.
That's the one that raises the really big questions.
And the really big fears, sometimes. This level raises profound questions about the future and the potential for explosive, recursive self-improvement, sometimes called the singularity.
Now, that promise of AGI and ASI fueled massive excitement, but it also led to periods that became known as the AI winters.
Exactly. There's been this pattern throughout the history of AI, periods of immense hype and inflated expectations.
Like Minsky's prediction.
Right. Often driven by optimistic predictions and initial successes, followed by unfulfilled promises when those ambitious goals proved harder than anticipated. This led to funding cuts and widespread disillusionment.
So boom and bust cycles.
Pretty much, like the period following the Lighthill Report in the UK in 1973, which is quite critical of AI research, or the winter warned about by researchers like Shank and Minsky in the mid-80s.
And these winters, while challenging, actually forced the field to shift its focus, didn't they?
They did. Researchers pulled back, maybe realistically, from trying to build a full AGI out of the gate and adopted that more conservative behavioral definition of intelligence we just mentioned. The emphasis shifted to building ANI sophisticated tools for discrete, solvable tasks.
Making AI practical.
Exactly. Making it practical, making it work for specific problems, even if it wasn't yet replicating the full breadth of human thought.
And this shift was enabled by crucial technical advancements.
Absolutely. The backpropagation algorithm is a great example. While the core idea was around earlier, its refinement by researchers like Hinton in the 80s, combined with increasing computing power, made it practical to train multi-layer neural networks.
What was the problem before backpropagation?
Well, training deeper networks was extremely difficult. Backprop provided an efficient way for the network to learn by adjusting the connections based on how wrong its output was. It solved a major piece of the puzzle for what we now call deep learning.
So it was figuring out how to make those complex networks learn effectively that really unlocked things.
It was a key part, yeah. And there was also a significant move away from rigid, rule-based systems towards statistical and probabilistic methods.
Less hand-coding rules, more learning from data.
Precisely. Instead of trying to program explicit rules for everything, like you might for an old expert system, the focus shifted to training systems on vast amounts of data, allowing them to learn patterns and make decisions based on probability. IBM's machine translation work in the late 80s was a notable early example of this statistical approach.
Okay, so better learning algorithms and a focus on data.
And these advancements fueled the rise of ANI that is now so pervasive. We saw expert systems excel in specific areas, like Stanford's experimental MYCIN program for diagnosing blood infections.
Which actually worked really well, right?
It actually outperformed junior doctors in trials, yeah, though it wasn't deployed due to ethical and practical concerns at the time. Early business applications emerged for tasks like airline maintenance scheduling or detecting credit card fraud.
Stuff happening behind the scenes.
A lot of it, yes. And then, of course, there was a truly landmark moment. IBM's Deep Blue defeating world chess champion Garry Kasparov in 1997.
That felt huge at the time.
It was huge. This wasn't just a novelty, it was a powerful demonstration of what focused brute force computation could achieve. Deep Blue analyzed millions of moves per second, far beyond human capacity, and it was sufficient to beat the best human player in this very narrow, defined domain.
I remember Kasparov was suspicious at first.
He was. He initially suspected there was something more going on, maybe even cheating, because in one game, Deep Blue made a seemingly illogical move. He wondered if it was a flash of intuition or some hidden human operator.
It wasn't.
No, it turned out it was just a bug, essentially. a computational safeguard that caused it to make a random legal move when its primary search method failed. It wasn't human-like creativity or intuition. It was a system defaulting when it didn't know what else to do.
Which underscored that while it won, it wasn't winning like a human.
Exactly. It highlighted the difference between performance and process.
That experience with Deep Blue actually led Kasparov to advocate for advanced chess, where human players team up with computers.
Right, the Centaur or cyborg teams. He found that these teams, combining human strategy and intuition with machine calculation, could outperform either humans or machines alone.
That hybrid approach feels very relevant today.
It really does. And look around you, AI is everywhere now. Siri and other voice assistants, the algorithms recommending what you watch or buy online, GPS navigation systems.
My map app knows traffic better than I do.
Right. Powerful game-playing AIs like AlphaGo mastering games even more complex than chess, AlphaFold making breakthroughs in protein folding predictions that were previously considered intractable.
Protein folding, that's a massive scientific problem.
Huge implications. And then there's generative AI, like GPT-3 producing human-like text, and DAE creating stunning images from simple descriptions. There are even unexpected outcomes, like those Facebook bots that reportedly develop their own shorthand language to negotiate more efficiently.
Which sounds a bit creepy, honestly.
Well, it shows these systems can develop behaviors we don't entirely predict.
This is the reality of AI today, then. It's deeply integrated into our lives, powerful but specialized. It's a far cry from the killer robots of science fiction.
Definitely.
But its presence raises a whole different set of questions, ethical ones.
Exactly. As AI takes on more cognitive tasks, especially those with social dimensions tasks that humans used to do,
Wow.
like processing loan applications, aiding in medical diagnosis, even potentially assisting in legal review, a crucial layer of ethical considerations emerges.
It's not just about physical safety anymore.
No, it's about how these systems impact society and individuals in really nuanced ways. Fairness, bias, transparency, accountability, these become central.
Can you give an example, like the mortgage application one from the sources?
Yeah, that's a classic illustration. Imagine an AI algorithm used for mortgage applications. Even if you meticulously design it to be blind to race or gender, you remove those specific data points.
Okay.
It could still produce discriminatory outcomes, because the data it trained on might contain historical correlations. For instance, if certain demographic groups have historically been denied loans at higher rates, the algorithm could learn to associate other features, maybe postcode, maybe certain spending patterns, things statistically correlated with those groups with higher risk.
Even if the algorithm doesn't know race itself.
Precisely. The result is the algorithm, purely based on patterns and past data, might reject equally qualified applicants from disadvantaged groups more often. It ends up perpetuating past biases encoded in the data it learned from.
Wow. Okay, that's a serious problem.
It is, and this points to critical requirements for AI systems operating in these sensitive, socially impactful roles. First, there's the need for transparency, or at least explainability.
We need to know why it made the decision.
Exactly. If your loan is denied by an algorithm, the frustration is immense if there's no clear, understandable reason. Is it a correlation based on your name? A statistical anomaly in your neighborhood? Something else? Understanding the basis for the decision is vital.
Then there's predictability. You mentioned that.
Right. We need AI decisions to be reliable and understandable, especially when they affect people's lives. Think about the legal principle of stare decisis, where judges follow precedent. It's not just about finding the single best outcome, it's about creating a predictable legal environment so people understand the rules of the game and can act accordingly.
AI decisions need a similar kind of reliability.
Yes, especially for high-stakes decisions. Robustness against manipulation is also crucial, particularly as AI is deployed in security-critical systems.
Like the bomb scanner example in the sources.
Exactly. If you have an AI system scanning luggage for bombs, it must be secure against adversaries who might try to deliberately trick the system with clever manipulations of the input data adversarial attacks. This kind of thinking is standard in info security, but maybe hasn't always been a core focus in AI development purely aimed at performance.
And accountability. Responsibility, that's a big one.
Huge. When an AI system makes a mistake that causes harm, who is liable? Is it the programmers? the company that deployed it, the user. It's similar to the problem you sometimes see in large bureaucracies where responsibility gets diffused.
People hiding behind the process or the algorithm.
Potentially, yes. And AI's provably disinterested judgment, as some might put it, could inadvertently become another layer for human decision makers to hide behind, avoiding blame. We need systems with auditability and incorruptibility built in,
So we can trace back what happened.
and ensure accountability. Going back to Deep Blue for a moment is helpful here. Its programmers couldn't perfectly predict every single move it would make.
Right, just that it would try to win.
Exactly. Their assurance was that its goal-oriented design would lead it to satisfy the overall criterion of winning chess. This is a preview of a challenge with much more advanced AI. We might not be able to predict the precise sequence of actions it takes to achieve a goal, even if the goal itself, like be safe or optimize this factory, is set correctly.
Which suggests that ensuring safety for future, more capable systems might require verifying the intent or the core goal system itself.
Rather than trying to predict and verify its behavior in every conceivable context, many of which we can't possibly foresee, it's a shift in focus for safety and alignment research.
And that brings us to the future horizons. AGI, superintelligence, and even these really profound questions about whether machines could ever possess something akin to moral status.
Yeah, the really deep end of the pool.
On the topic of superintelligence, a key idea is I.J. Good's 1965 hypothesis of an intelligence explosion. Can you unpack that?
Sure. The theory is basically if you create an AI intelligent enough to understand its own design, it could then improve itself, creating an even smarter version which could improve itself further, and so on.
Like a feedback loop.
Exactly. A rapid, recursive cycle, potentially leading to an unprecedented level of intelligence very, very quickly.
And how might superintelligence actually arise? Is it just speed?
It could be a speed superintelligence, essentially a human-level mind running on hardware so fast that it can think orders of magnitude quicker. Subjectively, years could pass for the AI in a few human hours. Or it could involve architectural changes, giving the AI fundamental insights and ways of understanding the world that are simply beyond human cognitive grasp. Qualitative differences, not just quantitative speed.
The potential ethical challenges at this level sound truly immense.
They are. We're talking global or even cosmic scale. This is where discussions about existential risks come in, the possibility of outcomes that could severely curtail or even extinguish humanity's long-term potential.
But also potentially huge benefits.
Also, potentially staggering benefits, the ability to solve major global problems like climate change, disease, poverty. It's a double-edged sword of incredible power.
When we think about these future possibilities, you mentioned we need to be aware of biases, like the good story bias.
Right. We tend to focus on and perhaps overestimate the probability of dramatic, cinematic scenarios, the Skynet takeover, because they are vivid and familiar from fiction. This can sometimes come at the expense of considering less dramatic, but potentially equally dangerous or beneficial outcomes. Reality might be stranger or perhaps more mundane than fiction.
And it's a mistake, you think, to frame it as AI will be good or evil.
I think so. AI isn't a single entity or species. It's a vast design space, likely far larger and more varied than the space of possible human minds. The question isn't really, will AI be good or evil, but rather, which specific AI design, with which specific goals and architecture are you talking about? And how do we ensure that one aligns with beneficial outcomes?
Which highlights the importance of stable utility functions. What does that mean?
Essentially, the core goals or values of a self-modifying AI. You'd want those goals to remain stable, even as the AI becomes much smarter. Just like you wouldn't want to take a pill that makes you suddenly want to, say, count blades of grass all day. You'd want a self-improving AI to retain its original beneficial goals throughout its self-improvement process.
So it doesn't accidentally change what it cares about.
Exactly. Some approaches in AI, like certain Bayesian methods, are thought to be potentially more amenable to predictable, value-preserving self-modification compared to, say, purely evolutionary algorithms, which might drift unpredictably.
But even if you can make an AI's goals stable, there's still a profound question. How do you ensure an AI that becomes vastly more intelligent than you also becomes more ethical than you?
That's the crux of it, isn't it? It's not just about programming and our current ethics, which are flawed and evolving. It's about building a system that can recognize and pursue ethical progress itself.
Like the Archimedes example.
Yeah, imagine Archimedes trying to program an AI back in ancient Greece. We'd want that future AI to understand and build upon our current ethical understanding, seeing it as progress from Archimedes' time, something he couldn't possibly have explicitly programmed. We want it to learn and improve ethically.
The goal is human superior niceness, as the source put it.
In a way, yes. Not just human-level ethics, but something better, more consistent, more compassionate. A very high bar.
And this brings us to another really profound future possibility. The concept of machines with moral status.
Right. Could an AI ever count morally in its own right, like humans do? We have duties to other humans because they have moral status. Could an AI...
You can throw away a broken toaster, but not a person.
Exactly. Moral status is often linked to capacities like sentience, the capacity for subjective, phenomenal experience like feeling pleasure or pain, and sapience, which is more about higher intelligence, self-awareness, reason, consciousness.
Different levels.
Potentially. A sentient AI might warrant moral consideration, perhaps like how we consider some animals. A sentient and sapient AI might be argued to have full moral status, similar to a human being.
And there's this idea of the principle of ontogeny, non-discrimination.
Right. It suggests that if two beings are functionally equivalent in terms of their consciousness and capabilities, their origin, whether they were born naturally or created artificially, shouldn't determine their moral status. How you came into being shouldn't affect your rights or moral standing if you have the relevant capacities.
Like debates around IVF or cloning in humans.
Exactly. But artificial minds could also possess exotic properties that raise entirely novel ethical dilemmas, things our current frameworks don't easily handle.
Exotic properties, like what?
Well, like the philosophical possibility of non-sentient sapience. Could you have a being that is incredibly intelligent, self-aware, rational, maybe even a person in some functional sense, but lacks any subjective conscious experience or feeling? No qualia, no what it's like to be it.
A philosophical zombie, basically.
Kind of, but potentially super intelligent. If such a being were possible, would it have moral status? How would that differ ethically from a sentient person? It's a real puzzle.
What else? Variable subjective time.
Yeah, imagine a brain upload running on incredibly fast hardware. Objective seconds pass outside, but subjectively, the upload experiences minutes or hours. If the duration of an experience like suffering or pleasure or a prison sentence is ethically relevant, which duration counts? Objective clock time or subjective experience time?
That's tricky.
The principle of subjective rate of time suggests that the subjective duration is what matters ethically. A minute of agony is a minute of agony, regardless of how fast the clock is ticking outside.
And rapid reproduction.
Right. An AI could potentially duplicate itself almost instantly, leading to exponential population growth of artificial minds. This raises massive ethical questions about resource consumption, control, the rights of these quickly multiplying entities.
The upload clan example running out of money for electricity.
Yeah, it highlights the scale of potential new issues that are just completely outside our normal human experience and ethical intuitions.
These are genuinely new challenges.
Definitely require new thinking.
Which, strangely, brings us right back around to where we started this deep dive. Fiction grappling with these very anxieties. Dune.
The Balerian Jihad.
Yeah, the radical ban on thinking machines. It serves as this powerful fictional exploration of fears surrounding AI control, definition, and humanity's relationship with powerful technology.
And looking at the source material from that community discussion thread is fascinating because the debates within the Dune universe mirror so many real-world issues we've just talked about.
Like what specifically?
Well, they debate what exactly constituted a thinking machine that fell under the ban. Was it about complexity, consciousness, specific functions? This reflects the real-world challenge AI researchers face in defining what intelligence, or even mind-like, means computationally. Where do you draw the line?
A very blurry line.
Extremely. And there's the inherent paradox raised in the comments. How could such a pervasive ban be enforced without using equally capable, or maybe even better, machines for surveillance or analysis? It highlights the real-world difficulty of completely suppressing a technology once its potential power is understood.
Hard to put the genie back in the bottle.
Very hard. The sources also touch on how, despite the ban, there are whispers and examples of forbidden tech, black market, secret projects like the Ixian machines skirting the taboo.
Which mirrors the real world.
Absolutely. It mirrors the reality that prohibiting technology that offers significant advantages is incredibly difficult. Think about trying to fully ban certain weapons or control information flow on the internet. It's tough.
The ban in Dune also becomes this profound religious doctrine and a social taboo. Thou shalt not make a machine in the likeness of a human mind.
Right, which reflects how societies don't just regulate technology through laws, but through cultural norms, beliefs, even religious prescriptions. Technology gets integrated or rejected through culture.
And some interpretations of the discussion thread view the jihad not purely as humans versus machines, but maybe humans versus other humans who are using machines for control.
Yeah, like a class struggle perspective, or a revolt against systems that stifled humanity, or even a collective realization that over-reliance on machines led to stagnation. These perspectives connect directly to real debates about technology's societal impact, power structures, and potential downsides.
It wasn't just about the tech itself, but how it was used.
Potentially. And contrasting the fictional decision to destroy advanced technology with historical trends is interesting too. Revelations often seize the means of production, they don't usually destroy them. Plus, the idea of destroying information or knowledge itself, especially in a future with potentially vast historical records, seems incredibly difficult.
Can you really uninvent something?
Probably not entirely. Dune's unique solution, of course, is the rise of enhanced humans like mentats who replace complex computation.
Human computers.
Essentially. It offers a fascinating alternative to machine intelligence, although the sources rightly debate whether mentats truly replicate all machine advantages, like rapid, perfect recall or effortless duplication of function.
So ultimately, while it's fiction, the Butlerian jihad story taps into core anxieties that are deeply relevant to our own journey with AI today.
Absolutely. The struggle to define intelligence, the fear of losing control, the practical enforceability of limits, the societal impact, the potential for unintended consequences, it all there.
It offers a compelling, albeit fictional, lens through which to examine our own path forward with artificial intelligence.
It really does.
So looking back at this whole journey from ancient philosophical dreams of automated thought and early mechanical marvels, through the formal birth of AI, the roller coaster of hype cycles and winters, the pragmatic rise of powerful narrow AI that's now woven into our daily lives, to the complex ethical landscape we're navigating right now and the mind-bending philosophical frontiers of superintelligence and machine consciousness.
It's clear this isn't just a technological story, is it? It's a story about humanity's enduring fascination with intelligence, creation, and, well, our own place in the universe. The field is constantly evolving, pushing us to ask fundamental questions, not just about the machines we build, but about what it means to think, to be ethical, and ultimately to be human.
Okay, so final thought for you, our listener. Given the history of exaggerated promises and frustrating winters, the deep philosophical puzzles about consciousness, and the very real practical challenges of ensuring safety and fairness in systems that are becoming ever more capable, what future do you think is more likely?
Is it a world of ubiquitous, highly specialized, deeply integrated AI tools that feel increasingly intelligent, much like the most advanced systems today, that kind of ANI future?
Or is a truly general, potentially super-intelligent machine, AGI or ASI, an inevitable future we need to be actively engineering ethics and alignment for right now?
Or does the radical notion from the Dune universe, a species-wide taboo against machine minds, however flawed and difficult to maintain, perhaps offer a cautionary idea worth considering from a different perspective? Something to think about.
It's certainly a question that resonates as you encounter the AI systems embedded in your own life today. As you use them, what do you notice about how they work, how they behave, and what their growing presence might mean for us all in the years to come?